How's everybody doing this morning? GrrCON Day 2. I'm excited. All right. So my name's Kyle Andrus. My talk today is proof that Windows computer forensics is sexy. Yeah. Anybody do a sexy dance a little bit? Anybody? All right. So I'll better dance in a bit. So just for the quick disclaimer, the opinions expressed in this presentation and the information in these slides are solely my own. I am not in any way representing the opinions and views of the company I work for. There, won't get sued. Quick introduction. So I've been in the IT field for about 10 years so far. And started in college as like a lab manager, taking care of a lab that we had about 5 courses we took care of. And then from there, I actually graduated in 2008 during the recession, so I was like, yeah. All these jobs lined up from an internship, and then they're all gone. It's like, and it's gone. So I started actually off in a web hosting company. And anybody here ever worked in a help desk for a web hosting company? So you guys know when I say, like, web hosting companies don't really discriminate about what sites they host. And so, like, one of my first, websites I had to fix on the job was this guy's, the images on his website weren't coming up at all. So like, I'd go in there and start fixing it. And I'm like, let's see, what's the URL? collegeboyfeet.com. All right, wait a minute. So I didn't want to fix those images, but I got them back up. So after that, I got hired by my current company, a Fortune 500 utility company. Been there for about 5 years. I started off in the desktop engineering side and kind of like the third level support. So a lot of stuff that I did was, OS and app deployment, working with clients to figure out what they want. Also, I did a lot of troubleshooting. And utility companies in general have a lot of legacy apps. And so a lot of times someone would come in, they'd implement it, or it'd be like a custom written script, and then they would completely forget, or that person would leave, and no one has any idea how it works, but if it doesn't run on time, then you're screwed. And so I would be thrown in, and I would learn any technology that was thrown at me, figure out how it works, what's going on. And so I got really good with like sysinternal tools, using like Procmon and like Process Explorer, using things like Windows DBG to try and figure out like why it's broken, what's going on. Was it actually a patch that installed that now prevents this application from running? I'd do stuff like that. And then when I got into forensics, so I moved over to our security side and our cybersecurity operations center. And started working there, kind of doing endpoint security, so like McAfee, encryption, decryption. It's starting to now push into forensics. And so last year I actually took the SANS course for Windows Forensic Analysis, which was a lot of fun. Like I really got to know the operating system a little more, kind of in a different perspective. Like, it's one thing if you go and fix things, because it's just like you don't really get as much time as you'd like to really learn it. And compared to forensics, where you really need to know how the operating system works to a much detailed level. So I really enjoyed that, and it's kind of continuing my addiction. So just some quick general terms real quick to talk about. Computer forensics is a branch of digital forensic science pertaining to legal evidence found in computers and digital storage media. Thank you, Wikipedia. And so my personal definition for computer forensics is figuring out which roommate logged in your computer over the weekend and downloaded all those cute Russian girl pictures that actually had malware in it, and then you got crypto locker, and now you owe somebody 10,000 rupees to try and lock your computer. Yeah. Digital artifacts is an object of digital interest. This can be That was beautiful. Security conventions, let me tell you never know what happens. And so a digital artifact is kind of like, a piece of evidence you can find, whether it be like an email that has like the smoking gun, like I emailed the boss and said, I'm going to kill the server tonight. Or, like a configuration file for something. So I always think of artifacts, and I'm going to use the word artifacts a lot to refer to all these points of evidence that you can find in the operating system. But I think of artifacts as like Pokemon, you got to catch them all. So, and then link file, if you've never heard of like link file, basically just a shortcut file, right? What's kind of interesting about link files in the Windows operating system is they're created all over the place for a different variety of reasons. A really quick way to think about it is you look in your user profile and the recent items, you'll see all these files that you've recently played with. You'll see like a thumb drive, the Kingston thumb drive that I plugged in, or like a home drive that I went to, or the document of how to convince your boss to give you a raise. So these are actually, they're all just shortcut files linking back to your recent items that the operating system will use. So you didn't create these, the OS did automatically. And so when I was putting this presentation together, I'm going to make it really easy. We're just going to kind of stick with Windows 7. And we're going to be going through this like at 1,000 miles an hour. The idea for this talk, to try and make it sexy, was to just show you very quickly like where are some areas that you could look for if something happened to you, right? So if you left your computer unlocked and you went to the bathroom, and if you have coworkers like I do, then, bad things happen. So, but I noticed that as I was going through this, a lot of the like really cool artifacts that you find were all in the registry. And so if you're not familiar with like the Windows registry too much, some of these will be like, well, how can you really know that that's, So I threw in this little blurb here. So in general, the registry, if you've never looked at it before, you're going to have a couple of root keys in here. So like current user and HKey users. HKey users is going to hold like every single profile that comes in. You're going to have a key that gets created down there, and it holds information about the user, their app settings, folders, stuff like that. And then in current users, it's going to be the you can hear that guy yelling down the hall. Somebody tase that man. And so in current users, it's going to be the current logged in user, right? So it's going to be their profile, their user hives all loaded in there. A lot of my examples just make it easy. I'm pulling out of the current user, so I'm just doing myself. And then the local machine, you're going to have all the information about like the OS, software, and also your security settings. And so these locations, they're good to know where they are, because if you ever take like a disk image or you're doing like a forensic case, you'll want to know where these are and where you can grab them. And so if you're looking for like the HKey local machine, the main registry hives that are in there, you'll find software, system, security, and SAM file, and system32 config. Something you might not know is that in the same directory, there's a regback directory that actually contains a copy of those hives for every 10 days. So that could be pretty useful, because if you've got someone that's like, I know these guys do forensics here, so I'll just wipe out my hives. So you might have a chance to pull out some registry artifacts from the backup if they didn't know it was there. The other locations for like HKey user, in the user's home directory, you're going to have ntuser.dat, and that's going to hold all those configurations and customizations like for the users and more. There's also a user class.dat, which you might not be familiar with, but when Windows 7 and stuff came along and you have UAC, or user account control, that was created as a part of it to deal with some of the security risks. For example, you don't want a user process editing some of the important system registry stuff, right? So instead of putting those settings or those configurations that would normally write over in like a standard registry, it'll actually just write to like a user class. Kind of, sort of. Another important thing that you may have never known is there's actually a last write time in the registry. And so on the left, you see the folders. These are the keys. And on the right, you'll see the values. And so what's cool is the folders on the left actually get a last write time every time that the keys on the right are usually modified. So this can be pretty cool because, for example, on the right, in our values, you see this thing that says MRU list. Is that big enough for everybody? Okay. So the MRU list would be the last or most recently used. And you'll see it says CBA, and that you see that we have values that are CBA, and the C being the first one in there. So the last thing that I ran from this run MRU, and by the way, run MRU is when you do like the Windows R key or Windows run to run a command. And so it actually stores. So if you ever do that, like the Windows run, and you see the history of all the previous commands that you ran in there, they're stored in here. And in particular, this is in someone's user hive. So this is specific to the user. But anyway, so from the MRU list, we can see that the last command that I ran was C. And we look at C, and it was like I ran this crazy conemu/1. And so I know, because I can look at the last write time, that the last time I did that was actually at 10/11/2014 at 339, right? Just kind of like a general example of last write times. Also, something interesting you may not know is that registries are very similar to file systems. They have allocated and unallocated space. And so if you delete registry values or keys, there's actually the potential that they could still be there. Now, there's not a lot of free tools that do this well, but there's one like named Yaru, or yet another registry utility, I think. And this one, as you can see here, it's got the X's. That's actually showing deleted registry entries that were in there. So kind of nifty because, you know, again, if you think you're smart, you're like, I'm going to have my script go in there and just delete the keys that he's going to talk about. Easy. Like, oh, you could always go back and potentially pull those unallocated ones. It's always a cat and mouse game, right? Another tool that's very popular, written in Perl, is Regripper. And so this can be used to parse out all the different artifacts out there. There's hundreds of plugins that people in the community have written and the authors have made. And so you have like two versions. You can do it from the command line where you can run specifically just the module that you're looking for and the specific hive that you're looking for. And there's also like the GUI where you can basically put in a whole hive and just parse everything out into this awesome text file that you're kind of reading through and you can barely see what you actually just did. But that's just me. All right, and there's also PowerShell. And so in PowerShell, you can actually do some of this. So if you're not familiar with PowerShell, that's awesome. It's kind of like Python, but, you know, it's better. No, I'm just kidding. So what you can do in PowerShell is you can actually traverse the directory. So I can do hkey. So this is hkey current user, right? And so I can walk through this. I can do software, you know, Windows. Whoa, what am I doing? I'm sorry. Microsoft, Windows, current, Explorer. They don't make these things short in the registry, by the way. I don't know. So in this, so currently we're looking at someone's current user. No, actually that's me right now, duh. And if I wanted to look at the last write times, there's actually a module that was written by Microsoft that's on TechNet. And so I wrote a little alias to use that. So if I do like an LSW, whoops. This is an alias I wrote into my PowerShell profile. It actually parses out each one of the keys that are in my Explorer. And this will have like any interactions that I have in the Explorer when I logged in. There's a lot of artifacts in here that deal with like remembering my settings and stuff like that. In particular, we could look at the word wheel query. And so this is whenever you do like a search. So if I'm like, where's my taco? Right? So if I do, whoops, gotta click on things. It's amazing. You can see that, you know, this write time for that key just got updated, right? So if I actually go into word wheel, and then this is kind of the painful part, but if I do, whoops, get item property, and then this directory, you can see here that here's the MRU list that we're kind of talking about. And the MRU list is pointing towards what? 6? So if I look at 6, I can see that, where's my taco? So just kind of another, you can do it from PowerShell, but you got to really write some aliases to make your life easier around it. Switch back. So again, so this talk is, introduction to registry ended. So this talk in general is when I started looking into forensics, it was kind of about how I could prove if something happened when I walked away from my computer. Because again, like at my work, if you do walk away from your computer, you'll get awesome backgrounds like this. There's also somebody that wrote a program called Anoyatron, which will randomly lock your computer every X amount of time. Yeah. And it's on a network share, so it's just like network share, enter, walk away. You know, and so a lot of the artifacts I'm looking at are just kind of pertaining to that. Some kind of touch into malware analysis if you want to like look in these locations, but for the most part, it's just kind of like real easy stuff. So sexy time. Computer left unlocked. So we're going to look at real quickly, like, you know, if something was plugged in, was it a USB drive while you were away? Was there an app execution? Was there a file modification? And then did someone open a command prompt and kind of run something? So for USB forensics, this is by far not like a complete list at all. There's a researcher that went on and he was talking about how when he plugged in the USB drive and started doing the analysis on the artifacts that were modified, it had over 70 artifacts that happened when he used a USB drive. So this is like 5. So the first one, I love this log file so much in Windows. Does anyone here had to like troubleshoot hardware problems with drivers and stuff? Yeah. This log is fantastic because it'll actually show you the first time that a device is detected by the operating system. And it'll give you information about, where it looked for drivers and what drivers it selected, and then if it had errors and stuff like that. But for USB stuff, we can actually use this value to get the first time that the device, oh my gosh, it's not good. Don't worry about it. So it'll be the first time that the device ever appeared in the operating system. And we can also see the make and model, and more importantly, we'll see this unique serial, which is important. Because we'll use this to basically look in all the other artifacts to match them all up and make this awesome little diagram. And so the next place that we can look at is going to be in HKey local machine, and it's going to be the USB store. There's also a USB one, which will have like any USB device that's plugged in, but USB storage is what we're going to look at. And the first thing that we'll do is we'll find it in here, and we'll see that we'll have this unique serial. So another location that we can see this unique serial and match it up with like the first time that was ever plugged in from the log file. So it also, if you ever notice on your serial, if the second character in is actually the AND symbol, that actually means that the operating system didn't find a unique serial on the device and that the OS generated it. So the next place we can look is in the Windows portable devices, also still in the local machine. And from here, we can actually get a volume name of the USB device that was there. And so in particular, this one's called Not Malwares. Trustworthy. As we continue on, we also have mounted devices. So these are all system like plug-and-play type of artifacts. So in mounted devices, we'll at least get the drive letter. And so like the volume name and the drive letter are pretty important to find out, because as you're going through artifacts, you'll see different references and be like, oh, it came from this volume, and it had this executable, or this drive letter was used for this path, and like, okay, so how do I know? You look at the timestamps of when you found that artifact, and you can look at the USB devices that were plugged in at the time, and you can kind of start matching these things up. And then we also get this unique GUID that's created. And this GUID can actually be used to trace it back to a user. So within a user's registry hive, you'll have this mount points to, which keeps track of all the devices that the user mounted. And so we'll see that GUID in there, which we can use to find the last time that, for example, the device was plugged in. And we can also know what user it is. So we can prove that, the first time we ever saw this device was yesterday, and the last time that the user used it was this morning when he executed the piece of malware that screwed all of our systems up in the SCADA side, and the company crashed and burned. Got him. There's also some free tools out there that are really nice. Nirsoft, if you've never heard of Nirsoft, you should definitely check their site out. They have a lot of really quick Windows tools that you can use, especially forensics. USB DView is one of them, and it's pretty nice because it gives you a really fast way, and this will actually pull all USB devices. And so when we're looking at this, we can see that the data traveler that I have here, one thing to note here in a second, but last plugin date and the serial number. What I did notice was when I was testing this on Windows 8 and when I was on Windows 7, this create date column is completely off. So no matter what tools you use, everybody knows that you should always know how these things work in general so that you can always validate what you get back from tools. And this was a great example of that. Because at first I completely trusted it. I'm like, this is an awesome, oh, wait a minute. There's also a command line versions out there. USB history is one of them. And we could use that to parse out, and you'll see similar information. You'll get the serial. What about a rubber ducky? Anybody familiar with a rubber ducky? So for those of you that aren't familiar with rubber duckies, they're basically when you plug them in, they get detected as a keyboard, right? And so we all know, has anyone here had to actually install drivers for a generic USB keyboard? Yeah, no, because they're always accepted. And because of that, this device takes advantage of that. So once you plug it in, it gets detected, it waits a little bit, and it'll actually run keyboard commands. So think of anything that you could do with a keyboard, you could just do with this. So people have been amazing. Like they have made reverse shells, they have done exploits, they've run PowerShell code. It's all over the place. Oh crap, I forgot internet. Don't worry. So I was going to do a quick demo here, and I actually have a USB rubber ducky here. And what it does is it uses the Windows run command, and when I plug it in, it's going to execute to one of my favorite YouTube videos. Never gonna give you up. No, that's not your guys' favorite. One hit wonder, I swear. So let's see. So wait here. Oh, there it goes. It runs. Whoosh. Bam. Full screen. Unable to connect the internet. Don't worry about that. That's actually YouTube playing. You guys just can't see it. All right. And so if someone did this to you, some ways that you could kind of detect if this activity happened. So again, like in the idea that you walked away from a computer and you came back, we could look at, if I can find it. Oh, here it is. So here's that USB-D view. And if we refresh this. So right here, we can see the times that this device was there. And particularly, like the last plugin date is what we actually trust because we know the creation date on this tool is broken. And we get the serial number, and we can see that it comes up as a human interface device, so a keyboard. So if you walk away from your computer and you come back and you think something's weird, and you check out and you see a keyboard was plugged into your computer, that's a little weird. So let's go on to to something happen. So like application execution. 1 second, getting a dry mouth. So there's a couple of artifacts we'll look at for that. So user assist is really neat because this is used to populate a user start menu with like the most recently executed things. If you notice on the right, it's super easy to read. I mean, whew, you guys can't read that? So all the entries on the right, or all the values, I should say, are actually encoded in ROF13, which actually is pretty easy, and it's a really fun test in PowerShell if you want to try your PowerShell skills out, to basically decode that. And you can get a lot of good information. You'll get like the name of the application or like a link file that was executed. You'll get last run times and the number of times that it was executed because it keeps track of that so that it knows that this is your most frequently used app. Nirsoft has another tool called User Assist View, which will show you this kind of information. So you can see here like the command prompt that I ran. I've ran it 3 times so far, and the last time that I ran it. But you can see PowerShell actually on this link is 7, so I use it more. Anyway, another spot is prefetch. A lot of examiners use this for a while, but with SSDs, Windows 7 it usually disables it by default because it doesn't need it anymore. The idea of prefetch was that it would store your most commonly startup programs and like applications you run to try and start them up faster for you. And so the files that were generated like in this directory, you can see like somebody was running this awesome exe called hackety-hack.exe. And so you could actually get information out of that file if it wasn't an SSD for execution time and the name of executable in its path. So now we have building up these different locations that we can validate across the way. Movie cache is pretty interesting because it's in the users directory and it's actually in that user class.dat we talked about. And so it's part of the Windows language like translation piece. So for a user, as they're running anything, you'll see the executable and full path name, and you'll see on the right like the title of the window. What's neat is a lot of malware people who losing words here. So a lot of malware will sometimes get caught in here because it's in the user class.dat and might not be modified. This is probably one that shocked me a little bit, especially because of my background in like applications, was the application compatibility cache. And so this is in the system, or in the HKey local machine system. And so anytime that you run an application in Windows, it's going to check to see if this has got any old legacy issues. So you can imagine trying to run like an old XP application. And some of the easy things that Microsoft developers might have known that old legacy apps used to do in previous versions, they might have automatic remedies, or if you have shims created to take care of some of those application compatibility issues. So the operating system is going to keep a copy of the executable name and log the last time that you use it. And so this cache is awesome because it'll catch almost any executable that you run on the system. So another great place to look for malware, or if somebody opened up Word or something else or other things. So let's look at file manipulation. And so we got a couple for that. An important one here is like with recent docs. And so recent docs is another cool directory or artifact that's in HKey current user. And so within this directory, or in these key values, you'll see all these file extensions on the left. For example, you'll see .docs here. And so underneath each one of these keys, the values on the right you'll have all of the last, up to the last 30.docsx that you ran. And the fun part is you can use this to find out when was the last time that you ran a document, like a Microsoft document, or the last time you opened up a text file. So not only could you see text files that were in there, you could also see, well, any text files that you may have edited by this user, but you could also see the last write time of the last one from the MRU list. So in this example, we're looking here at 2, and the 2 value, see, I was looking at a picture of catspace.jpg. I love cats, by the way. And then another HKey current user artifact we can look at it is comdlg, or the Common Dialog Library. And so this library is kind of shared throughout any application that the user runs. And so it's kind of it's similar to like recent docs, but in general it'll keep track of the last visited PID that we have here. Will show all the last executables that the user ran. So if you had an application that was going to be like, actually a better example would be with the OpenSave PID. One second. So with the OpenSave PID, it also keeps track of any of the recent documents you edited. And so the idea behind this is that if you open up Notepad, right, and you go to like open something and you go to type and you see that, you know, most recently used in that drop-down box, it'll pull a lot of that from here. It'll be the same for like documents, HTML, JPEG. And you can get the last executable, the last open and saved files, and the last write times from it. And there's another Nirsoft tool that you can actually look at that. So the open save files view, and we can see that I was opening a lot of cat pictures at the time. I'm an addict. And so we also have temporary internet files. So this is one that kind of surprised me, because the last thing I'd expect is that Internet Explorer was keeping track of files that I opened. So I know that it would keep track of internet browser, you know, my browsing habits and everything I do. But I didn't think that it would do that. So you can actually use this artifact to see if a USB drive was opened up. You'll see instead of a C, it could be like a drive letter. And so then, what about if something happened, like if we launched a command prompt or a command was executed? So how could we look at that? I mean, the easiest way to do it, well, not really easiest, but we can take a copy of memory. And so once we get a copy of memory down, we could then analyze that with a tool called volatility. Are many people familiar with volatility? Yeah. So volatility is very nifty. So similar to like, you know, RegRipper, it's really community driven. It's written in Python, so it's portable between systems. And as you can see here, like the modules that are currently loaded, I could look at user assist information that's stored. So any of like the registries that are currently loaded into memory, I could open those up, and basically someone wrote a nice Python module to parse those out. And if we go up here a little bit more, this mouse is so touchy. And ones that we'll do right now is like we have command line, which will show any command line arguments. And then another one is consoles, which will actually display all the console information in the command prompt or PowerShell that you launch. So if we ran this real quick, I pressed enter, my hard drive made a squeak noise. That's not good. So, tool's a little slow at times. Let's see, let's parse it out. Yes, oh yeah, sorry. So, ahead of time, like usually taking a memory image, depending on, you know, with machines, the size or the amount of memory that machines have nowadays can be anywhere from, you know, 4 gigs to 16, 32 gigs. So it gets kind of interesting, because if you want to do like a remote acquisition of memory on a machine and you have a distributed network, and some of those links may only have like a T1 or something, that gets pretty difficult to take a remote image without taking down the site's network. I mean, that's when you might have like staging areas at each site that you can move the image over to. But so in this particular one, I created a VM that only had a 1 gigabyte or 1 gig of RAM. And so what we can see from this the first thing we can see that this was a command prompt that was open. Then when we look at the command, when we look at the commands that were run, while I was away from my computer, we can see that someone ran and created evil dude, sweet password bro, added them to my system. They then proceeded to add them to the administrators group. They CD'd into temp, they looked in the directory, and they ran dump it to take a copy of memory. Jerks. So what we're missing out of that, though, is, what about the information that was displayed in the console that we missed? So we saw the commands that were run, so that's what consoles can do for us. Oh crap, I flew through those slides. That's what you get for being nervous. Thanks. My first time speaking at a security conference, by the way. How am I doing? Like, yeah, not bad. Yeah, thank you. What I'm looking to do is to kind of make this sexier and sexier the more that I learn. So eventually I'll be like, hey, check out the sweet stuff. Like, and like flying colors will go across and cats everywhere. But you gotta start simple, right? Yeah, I can do that, yeah. That's a hard one to beat next time if I ever get to talk in, right? Had a guy with a shirt off running here. All right. Yeah, that's true. Oh, yes. Even better. All right, so that got done. So if we take a look here, we can actually see what happened in the command prompt. So typed in, sweet password, bro, And then it's funny because it actually got prompted that, the password entered is longer than 14 characters. It might not work in Windows 2000. And then that they actually went through and they hit yes to add that in. And then, of course, that command was successful, right? And then when they added it to the administrators group, it was successful. And so, they CD'd into the temp directory when they did their dir. They got all these wonderful things, dump it's in there, hackety, hackety, hack. And sexy cat pics of text. That's my secret file where I keep all my good pics. And then, of course, they ran dump it. Which, as we go down, we can see that they ran it. Are you sure you want to continue? They did select yes, and it processed probably successfully. Kind of a neat tool, right? And there's a lot more you can do with it. There's volatility is a very powerful tool. So, what do we know now? If we did leave our computer unlocked and we're suspicious that somebody might have messed with it or done something, we know any USB devices that may have been plugged at the time, and we can see the timestamps from when it was first plugged in to when it was last, especially, and then we can also tie it to the user, which if you're still logged in, that's going to be you. We can see what applications that person may have ran at the time, what files may have been modified or saved while we were gone, and then what commands may have been run as well. It's kind of like a very fast run through some artifacts. So here's some references and tools. Yeah, it was a little fast. But a couple announcements to slip in here, though. Anybody around like Jackson, Michigan? Guys? So starting in January, gentleman Matt Johnson, who's right there, and myself will be starting up a misec Jackson. So it'll be a security group. I'll be having another talk that I'll probably present. I think I'll be doing automation with PowerShell and McAfee EPO. So how many people run McAfee or have to deal with it? Okay, yeah. Have any of you used like the web API? Oh my god, it's so beautiful. You can automate like literally all of the things. So if you're interested in that, definitely hit up. We've got an email address, info@misec.org. So if you're interested or if you want to present, let us know. We're a very open community. We just want to have fun and basically learn. Also, PoshSec. How many people are familiar with PoshSec? So PoshSec is was created to fill the gap between native tools and commercial tools to enable system administrators and information security professionals and auditors to level up their security on Windows. It's also where like any of the tools that I'm going to be writing for forensics, like kind of parsing out some of those artifacts from the registry and the file system, I want to have those to be native tools that you could just drop and go instead of having an executable or something else. So anything like I may develop, I'm actually going to donate over to the PoshSec community. And there's a lot more you could do. So if you've been itching to get into a project, PoshSec is a great one to jump into. So definitely give it a shout out. And that's also Matt Johnson and Ben 10, if anybody knows Ben 10. And that's all I got. 35 minutes. Yeah.